In this last session, we will present to you Astro-COLIBRI. I will start with a more technical presentation, and Fabian will take over at half of the presentation to give you a live demo about Astro-COLIBRI. So let's start with an overview of the idea of Astro-COLIBRI and also an idea of this workshop. I've shown you this slide in the introduction session, but now I would like to spend a little bit more time on that and explain you in each area why we have chosen you as experts. And here I show you the talks here in red with red border that have happened already, and those with blue border that will happen over the next days. To illustrate you that we have experts from all of these areas here that will talk about different topics, and the nice thing is that that should trigger discussions between different areas of the complete multi-messenger picture. So here on the left we have obviously these different transient event classes. Here we have different, and that's by far not complete, different monitoring observatories that observe the sky all the time for different particles, different energy ranges, and so on. And whenever they find something interesting, they will issue alerts with the help of different alert pipelines over here. And again, here we have different speakers talking about different pipelines. And the goal is, as we've heard several times already today in talks, is to trigger follow-up observations, ideally in different energy regimes and with these mostly ground-based telescopes specialized to better resolution and different particle types and so on. The current difficulties are that these alerts here are sent through different pipelines that use different formats, so they differ in the amount of human and machine-generated content. So for example, here the ATELs, astronomer telegrams, are just human-written completely. Then you have these WO events that are machine-generated and more easily read by machines. That's why they're used, for example, in the HES and MAGIC alert pipelines and follow-up systems presented today. And the challenge is especially looking at the increasing number of these alerts that we will get due to new missions, better resolution, and so on. We need to have a system that helps us to, as humans, to keep overview of all of these alerts. And that was basically the idea of Astro-COLIBRI. We listened to these different streams, try to get the most interesting alerts that interests our community and tries to accumulate also additional information from these alerts using third-party websites where we can get additional data and information about an event and position in the sky, and compare the incoming data with our real-time databases, also to see if, for example, the incoming alert is just an update, and to combine the information that we have had already from previous alerts. Then the idea is that we send from our central API push alerts in real time to our users that have the app installed on mobile devices, so that you get a nice push notification about an ice event here, for example, that a neutrino was found. And as a user, you just click on that push notification and the app opens, and you will see the event where you can easily perform cone searches and have access to the visibility of many different telescopes. So you can see if it's worth to look further at the event, if you can really make follow-up observations or not. And we provide many links to other websites where you can get further dedicated information about it. And Fabian will focus on the second part about how that works and show you all the details on the website, because we also provide Astro-COLIBRI as a website. The idea really originated 5 years ago after the neutrino event that was detected in September. And then 6 days later only, there was a Fermi-Lot ATIL at that time, so human-generated message to the community, that actually Fermi found the Texas source to be within the uncertainty area of the neutrino event, and that was flaring at that time, as you can see here. In the FAVA, so the Fermi all-sky variability analysis, that took the community like 6 days until that connection was made, and that was the starting point. And Fabian told me that he was there at that time at the conference in Amsterdam. I think Sarah was organizing, some other participants were there also. And I can imagine that you were really discussing then over dinner about that event. And at that time you had all the information because FAVA was existing already. You could perform manual cone search and so on, but it was just difficult to do that, especially at a conference dinner where you don't have access to your computer. Exactly, so all the tools were available at that time. You can manually, of course, calculate the visibility window of your favorite telescope and could check if you could see that source in the next night or immediately, depending on the type of telescope that you're using. And the difficulty was, just to summarize that there wasn't one easy to use interface that you can use even when you are on the way or on a conference dinner. And it took some time, so now 5 years later, but now we have with Astro-COLIBRI such an interface with an app that you can use. And if that app would have been available at that time, the cone search around that ice cube event would have looked like that. So you could have seen easily that Texas source is nearby. In red, you see all the known sources that are also known in PeV, compared to just Fermi sources from the 4FGL catalog. And then you can simply click on details and look at the FAVA website to see the activity. And that would have just costed a few seconds to do that and to see that the source was active at that time. Now, just a few days ago, we had a new ice cube neutrino alert, also nearby that source, and the Texas source is again within the uncertainty. And here I know from several people that use Astro-COLIBRI to go to the details section and just checked for FAVA and have seen that there wasn't any Fermi activity, so no gamma ray activity. And that's something you could have checked within seconds, and which is much faster than it would have been without. There is not only, especially for neutrinos, there are several providers and services that distribute alerts, so Ammon for sure. Those who actually send the WOE events to the community. They also have an app that you can use and install, and they also alert you if there are neutrino events. And there's this own IceCube augmented reality app that also sends push notifications to you. And there you see a 3D visualization of that event, which is really cool. And I installed all of them, first of all, because I like the apps, but also to compare to Astro-COLIBRI, to see if we missed something and to compare the performance. And the alerts that are at the bottom arrived the earliest. So you see that Astro-COLIBRI is quite performant, so even faster than the own Ammon system. And we provide updates. So when, for example, so here, when the name is given for the event, for example, then we know, okay, we can click on that event, and then we get the further information about the circular that was sent around, seeing also linked to the GCN circular for the human-generated context from IceCube. And that's something we do for all the other alerts as well. So we also provide, obviously, for gamma ray bursts, for supernovas, and so on. And there it's crucial to have updates, because Fermi sends several alerts. And in Astro-COLIBRI, we have to update the event that we display with the newest information while still keeping the older information and combining everything. I would like to guide you quickly through the history of Astro-COLIBRI. As mentioned, the idea emerged end of 2017. By the end of 2019, there was a first prototype developed by Fabian and Anke, who was at that time master student here in Bochum and Paris. And at that time, we had a system that used Python in the backend, listening to all the events, making dedicated API searches in the Wo event API and so on. And in the front end, some JavaScript, HTML, and CSS. And that was the starting point, basically, presented at a HES collaboration meeting. Then I started beginning of 2020 working on Astro-COLIBRI as part of my PhD studies in France. And there, my goal was to make it more visually appealing and interactive. So that was like the first interface that you could use and provide your coordinates where you want to perform cone searches and so on. That was working in August 2020, still using the same framework as before, connecting Python and the front end. But I noticed at that time that the framework is a little bit limited and we are not able to put that tool onto a website, which I really wanted to do because that's easier accessible than having a tool that you first have to download. And therefore, at that time, halfway through my PhD studies, I decided to start all over again from scratch, destroying basically that product and using it only to compare with the new project that I was then starting. And that happened in September 2020. The next version then was the version that we published 2021 in August. So by that time, we also published a paper. And here you see the basic idea where you have in the left, and that's something Fabian will explain in a live demo in a few minutes, where you have here an overview of latest transients in a map, color-coded by the different telescopes that submitted the alert and different alert types. And you can, of course, filter by whatever you want to only display these events that are most interesting to you. Showing the list by arrival time, so the newest one on top. And here on the right, links to other websites where you can get dedicated information to that event. And it's a little bit more convenient than going to each individual website, typing in the coordinates or the event type. So here you simply click on the link and see the event in the website. And directly calculating the visibility for a tool that for an observatory that you can specify for the next night and the next month, and you can change it over that button over here. And we used Python still as a backend, but this time using an API, dedicated API, that can be accessed through HTTP requests from our front end that we then developed with Flutter, which is a framework maintained and supported by Google. So there's huge dynamic, and they still can financially support it quite well. There's a rapidly growing user base, and that framework is pretty nice because we can have the same code base for the website as for the apps with some small changes to the design. So it's easier to maintain a website and an app at the same time, also for Android and iOS, because we are still a small team consisting of like 3 to 4 developer that work on that. Over the last year, and after some a few hundred commits later, we ended up with the version 2 that has some new features like the timeline over here, showing you when the events appeared. Here again the list, now with a little bit more icons, also to because nowadays we also have many hobby astronomers and just the public looking at events, so we tried to make it a little bit more visually appealing to see directly what kind of event it is. And we have now science mode that Fabian can show later on. So we have an easy view for hobby astronomers or just interested people, and the science mode that's dedicated for providing the visibility to really schedule observatories and so on. And at last, I would like to show you the architecture. So here on the left, we have asked a professional artist to illustrate it. And here you see in that box where Astro-COLIBRI is represented. Actually, it's like a big system consisting of different important but modular systems. Like that one here that listens to all these different pipelines, WO events, GCNs, TNS, Transient Name Server, also ATOS and GCNs. And when we receive something, and we have here a small filtering so that we don't post everything to our API, but as soon as it enters our API, we process that event. So that's a Python-based API, using information also from third-party systems to see where the event is located and so on, performing updates in our database, both our static database that we use to perform cone searches when you use that in the app, and also updates to the real-time database. And the usage of the real-time database is that we have stream builders that are directly connected to our front ends. So whenever something is changing in your database or in our database, we will update it immediately to all the clients. So that's much faster than if clients have to ask and request updates. So that's optimized and much more performant. And we also send the alert as push notifications via the Firebase Cloud Managing backend to all different platforms. So using iOS, Android, specific pipelines to send these alerts to the devices where then users have access to stuff. At the moment, we still use storage for visibility plots because we create them in Python. It's much easier to just simply create them in our API, store them in a storage, and then just provide the links for the front end so that actually the front ends don't have to compute the visibility plots, but just the image stored here can be displayed. We work on some updates to allow for more customized interaction with the visibility plots, and therefore we will only provide at some point the so we compute the visibility here, but then send not the image there, but send the information there to then manually create the visibility plots in the front end based on the information that we have in the API. So the image from before now looks like that. So we have some input from many telescopes and observatories through different pipelines, listening to them, and after that process, users can see that and maybe use it for follow-up observations. And at that point, I would like to hand over to Fabian to give you a live demo about Astro-COLIBRI.